Hi Jory! Today we're going to be learning about inscribed angles. And before we begin, of course, we're going to have to define what an inscribed angle is. And an inscribed angle is formed using 3 points on a circle. That means inscribed angles can look very different. We could end up with an inscribed angle that looks like this. And the angle would be right here. Now we could also have one that looks something like this. And we have a quite small inscribed angle right here. Another one could look like this and be a very large inscribed angle. Now, one of the problems that people have with inscribed angles is they get them confused with central angles. Central angles are very different than inscribed angles because central angles come from the center. We've talked about these ones before. Now, a central angle is going to come up in this lesson. We are going to talk about central angles and finding arc measure for those. We've done that before. We remember that an arc for a central angle is equal to the measure of the angle itself. That is not true for inscribed angles. But we are going to be talking about arcs. And an intercepted arc in particular is what we're going to look at. And an intercepted arc is the arc that lies on the interior of the inscribed angle. So let's look at our inscribed angles. And our inscribed angle here goes from here to here. I'm just going to lengthen the sides a little bit to make it easier to see our intercepted arc. Our intercepted arc is everything that's inside of that angle. In this one, again, I'm just going to lengthen it a little bit to make it easier to find. This little tiny arc right here would be our intercepted arc. This one, in contrast, has a huge intercepted arc. You can see it coming all the way around from here to here. And that would be the intercepted arc. Now, like I said before, a central angle we know has the same measure for the arc as it would for the angle. With inscribed angles, what we're going to see is that the measure of the angle that's inscribed in a circle is going to be 1/2 the measure of its intercepted arc. So if we had a circle with an inscribed angle with a measure of x, this would end up being 2x. And we actually have the formula, the measure of the angle will be equal to the measure of the arc divided by 2. You can follow either path depending on what you're given. If you're given the angle, you might as well just multiply by 2 rather than put it into this formula. And that's what we're going to see here. We have been given the angle XZY. So the measure of angle XZY is equal to 70 degrees. And what we want to know is what is the measure of the arc XY. And I'm just going to call this T. Now I know that the measure of the angle has to be equal to the measure of the arc divided by 2. So I'm going to put in my angle measure, which is 70. And I know that that will be equal to my T divided by 2. Here I'm going to multiply both sides by 2 to solve for T. And I get 140 degrees is going to be equal to T. So that means the measure of the arc XY is equal to 140 degrees. degrees. Now, a lot of times they don't just give you one angle, they're actually going to give you a full triangle, and you're going to have to find things out from that. With this one, what we want to find is what is the measure of angle let's start with actually PQR. So I want to find this angle. I know that this angle is going to be the total arc divided by 2. And I'm told here that my arc is the same as 120. So PR, the arc, is equal to 120. So let's drop this into my formula. The measure of angle PQR is equal to the measure of my arc, which is 120, divided by 2. That means the measure of PQR is going to be equal to 60 degrees. Now there's one other thing I want to show you with this one, and that is to do with this angle. Suppose that I wanted to also find the measure here of angle P. So what is the measure of angle P? Well, notice that here we have a diameter of the circle. Since we have the diameter of the circle, that means that this entire measure here is half of the measure of the whole circle. So we know that a full circle is 360 degrees. That means that this is 180. If my arc is 180, then my angle is going to be half of that. So the measure of angle P is equal to 90 degrees. If you're ever asked to solve for an arc where the other 2 points would form a diameter, you can just tell me it's 90 and I would be okay with that. Now, here is a trick question. You really need to be cautious looking at inscribed angles versus central angles. People get them confused all the time, and on tests, quizzes, and exams, they're often going to show up together. This is our circle, and here we're asked to find the measure of each arc on the circle with RT as our diameter. So this is our diameter. We know that RPS is 110 degrees, and it wants us to tell what the arc RS is. This is a central angle, and we saw above that a central angle is equal to the measure of the arc. So that means that RS has to be the same as the central angle, 110 degrees. So this ends up being 110 degrees. And from that piece of information, we can solve the rest of it. We also want to know what RTS is. So look at this huge arc RTS. That arc is everything except for this arc. Since the total measure of a circle will have 360, we're going to subtract 110 from that, and we get 250 degrees. So RTS is equal to 250 degrees. Last, it wants to know what is RST. Well, RST is this. Since RT is a diameter, that means that this is going to be half of the full measure of the circle, which is 180 degrees for this half portion. So this one's included more as a warning. Watch out for those central angles. You solve it differently with a central angle as opposed to doubling or halving anything. You're going to keep them the same. All right, so let's look at some examples. We are actually going to ignore the 2 on here and just focus on these ones. Also, this question is incorrect. None of those options work because we're going to be looking for the measure of the angle NML. In order to find the measure of the angle NML, we're going to set up our equation first. We know that with an inscribed angle, the inscribed angle is going to equal half of the arc. So 26x is going to be half of 51x plus 3. So I'm going to just get rid of the 2. You can solve this a couple different ways, but I don't like working with fractions, so I'm going to turn this into 52x is equal to 51x plus 3, which ends up being a very nice problem to solve. Here I'm going to subtract 51x from both sides, just so that I can get my x's together, and I end up with 1x, or just x, is equal to 3. Now that we know that 1x, or just x, is equal to 3, we can use that to find the measure of angle NML. We're told that NML is 26x. So 26 times x, or 3, will give us our total measure, which happens to be 78 degrees. The options that are listed here are actually for the arches rather than for the angle like it asks for. We're going to skip this one and move on down to this. This is the longest problem. We're going to have several variables to work with. Just make sure that you're recording carefully when you do this. Here's what we know. We want to find x, y, and z, and we have arc here of 58 degrees. And an arc of 106 degrees over here. Now, knowing what we know about inscribed angles and intercepted arcs, I know that x will be equal to half of this entire arc. And this entire arc is equal to 58 plus 106, which is, let's see, 164. Yeah. So we have a 164 degree arc. So the measure of angle x will be half of that, which is equal to an 82 degree angle. Now, let's see what other one might come easily. Z, I don't really have a nice arc laid out there, but if I looked at y, I can see that y opens up and it happens to be every bit of the circle that we haven't already looked at. So I'm going to look at just y and its arc. I know that this arc is going to be 360 minus 164, because this arc is everything but the 164 degree arc that we already found. So that means that that arc is equal to 196 degrees. So we can put this into our formula and find that the measure of angle y is equal to 196 degrees divided by 2. And that is, of course, 98 degrees. Alright, so I found 2 of my angles. Now, you can use arcs to find z, and it might take a step or 2 extra. I would rather, personally, find it using some of our old principles, but it's really up to you. If you want to find z using arcs, you may, but let's look at just this first. We know that this angle is 93 degrees. We know that x is equal to 82 degrees. We know that y is equal to 98. And we also know that if we wanted all of the angles here, it would be the number of sides, which is 4, minus 2 times 180. That's what we learned last section. So we're going to end up with a total angle measure of 360 degrees, because 4 minus 2 is 2 times 180 is 360. So I'm going to take 360, subtract by 93, subtract by 82, and subtract by 98, and I end up with my angle Z, just one last one we don't have, and that's equal to 87 degrees. Alright, that's it for today. Don't be afraid to ask questions if you have them. Otherwise, feel free to just start tackling that homework on the bottom of the page there. Watch out, you only need to do part A of 14. Hope things are going well, and see you soon.